Welcome back to RamZland. Today I want to show you how to identify different metal ions using the flame test. Check this out. All I'm using in this investigation are different metal salts. Here's cobalt chloride. I'm going to use barium chloride, calcium chloride, strontium chloride. I'm using lithium chloride, ferric chloride or iron chloride, and copper chloride. And I'll make a slurry using hydrochloric acid in my dropper. To begin, add a few drops of hydrochloric acid to each sample and create a slurry that you can hold with your nichrome loop. Once you've made a slurry of each sample with hydrochloric acid, take your nichrome loop and scoop up a small sample. We're going to start with our copper chloride, and this should produce a nice green flame. Let's check it out. Oh yes, look at that green flame. Isn't that beautiful? That's copper chloride. Just amazing. And here's our sample of lithium chloride. A little slurry on here. Look at that red flame. Isn't that beautiful? Lithium produces a beautiful red flame. And here's a sample of calcium chloride. A bright orange flame for calcium chloride. And here's our sample of strontium chloride. A little strontium on there. All right. Also a bright red flame for both lithium and strontium. That is gorgeous. And here's our sample of iron chloride or ferric chloride. We're going to get a little bit of slurry on our nichrome loop and see what color this produces. That is awesome. And that's iron chloride. And this sample is of barium chloride. Like kind of an orange flame coming off of the barium chloride. And here's our sample of cobalt chloride. Wow, look at cobalt chloride, definitely an orange flame. Just beautiful. So what makes these different colors that we see? Well, when you heat up these different metal salts, their atoms get excited and their electrons move to an outer energy level, but they're unstable at that outer energy level, and when they return to their original energy level, each electron emits one photon. That's a particle of light, and each photon has a specific wavelength and frequency. So in the case of lithium and strontium, you're looking at a wavelength from somewhere between 600 and 740 nanometers that through the light spectrum appears to us as the color red. But in the case of calcium, you had a shorter wavelength between 590 and 625 nanometers that through the light spectrum appeared to us as the color orange. Well, I hope you enjoyed today's edition of RamZland, and I'll see you next time.